Hello guys, welcome. So yeah, as you can see, today we are going to discuss about silver nitrate, and yeah, this is going to be a second video of our playlist in which we are going to discuss about organic reagents one by one in detail. So yeah, this is our second video of the playlist where we are going to look up at silver nitrate. Okay, so let's start. Okay, yeah. So basically, what it's used for? Silver nitrate will react with alkyl halides to form silver halides and corresponding carbocation. When a nucleophilic solvent such as water or an alcohol is used. So basically, we use silver nitrate in presence of a nucleophilic solvent like water or alcohol. These are useful. I mean, important too. The product depends on the nucleophilic solvent you are going to take because we'll be seeing down. Okay, this can result in an SN1 reaction. Okay, SN1. This is important. SN1 reaction. This is an SN1 reaction. Okay, it can also react in the Tollens reaction, giving carboxylic acids from aldehydes. So what is Tollens reaction? So basically we know that when an aldehyde is reacted with silver nitrate, it's reacted with silver nitrate in presence of ammonia and water. Okay, ammonia and water, it gives or it oxidizes into acid. So yeah, so basically we'll be looking at down. Okay, but AgNO₃, in presence of water and NH3 ammonia. What does it do? It's basically oxidize aldehydes into carboxylic acids. Okay, so yeah, example one, it's an SN1 reaction, conversion of alkyl halides to alcohols. Okay, so we are converting alkyl halides into alcohols. Okay, alcohols. Taking the bromine at the 3-degree position in cyclohexane. So what happens is already it's favorable for SN1 because if positive charge forms here, there is no point of ring expansion because 6-membered is considered to be more stable than 7-membered ring. Okay, and also it is at the 3-degree position, so no migration and anything. So this can be done as a SN2 reaction. So basically, bromine gets substituted by OH minus and forming HNO3 and HEBr precipitate. So here concentrate because OH is formed. OH will be formed, alcohol will be formed when you take H2O as the reagent. Okay, and if you react alkyl halide, okay, here directly we have taken 3 degrees, so this basically acts as a SN2 reaction itself. AgNO3 in presence of MaOH. Okay, MaOH. What happens is alkyl halides get converted to ethers. Okay, so basically here in water case H2O acts as a nucleophile, and in ethers case basically MaOH minus MeO minus acts as a nucleophile. Okay, so here we see that ether is formed, here we see that alcohol is formed, same byproducts HNO3 and here AgBr, here AgCl precipitate. Okay, then the tolerance oxidation, we have already seen this. Basically an aldehyde reacted in presence of AgNO3 and ammonia and water gets oxidized into acid. So till here are the reactions. Now let's look into the mechanism. It's easier, but yeah, but see, SN reaction, typical SN1 reaction, and if you guys already know this, this will be useful as a revision for you, or for the guys who doesn't know this, pay attention. It's an important reaction. So silver nitrate AgNO3 has good solubility in aqueous solution. This statement is very important. Has a good solubility in aqueous solution. What does good solubility in aqueous solution basically mean? So when we say a substance is good soluble, I mean well soluble in aqueous solution, it means that it can dissociate. It can dissociate into ions. And we see that AgNO3 has good solubility in aqueous solution. So basically, AgNO3 having good solubility in aqueous solution implies that AgNO3 can be dissociated and be existing as ions Ag plus and NO3 minus. So this is so important. But where we see that AgBr, AgCl, AgI do not have good solubility in aqueous solution. So hence we can say that this doesn't dissociate well. Okay, and hence we know them to be having more covalent nature too. We'll be discussing about that further. Okay, so Ag plus coordinates to halide, which then leaves forming a carbocation. The carbocation is then trapped by solvent like H2. Okay, here we are using H2, so automatically the nucleophile is H2 minus. Okay, so let's look into the mechanism. The alkyl halide, when it is reacted with AgNO3, forward reaction seems to be a little bit less favored than the backward reaction. And see, AgBr, what happens is Br takes away the electrons, creating a positive charge. So what happens is carbocation is formed, and the Br minus reacts with Ag plus. I have said you, AgNO3 is going to exist as ions in aqueous solution. Hence, it is having good solubility. I'm stressing this point very much because it's too important. Okay, so Ag plus and NO3 minus, and hence it is having good solubility in water. Basically, uh, it forms a PPT AgBr and goes out. Okay, so carbocation, and then we know that nucleophilic attack happens. H2O, the solvent, acts as a nucleophilic solvent attacking on the this thing. As we can see in this step, the precipitation of AgBr as a solid drives the reaction to the completion. Okay, so it's basically a confirmation of something. Okay, so now water acts as a nucleophile. Water acting as a nucleophile and gets stick to the carbocation in that position, and OH2 minus H plus goes out, creating an alcohol. This is a simple reaction. Okay, either of H2O or NO3 both can act as a base here. So yeah, and here we used H2O as the base, sorry, as the solvent. If we could use MeOH as a solvent, and MeO minus would be this, what do we say, nucleophile. So here we would get an ether instead of an alcohol. Same, absolutely same reaction. Only the product is going to change, and we get the byproduct as HNO3 and AgBr. Okay, that's it. AgBr, it's yellow precipitate. Okay, AgI is pale yellow and AgI is yellow, bright yellow. Okay, so yeah, this is the whole entire reaction. And quickly let's sum it up. Okay, so basically AgNO3 uh, reacts in presence of water to form alcohol when reacted with an alkyl halide. Okay, and when in presence of MeOH as nucleophilic solvent, it does create ether, and also used in tolerance reagent. I mean tolerance oxidation. Basically, what happens is aldehyde gets converted to acid. One quick look at the mechanism once again. AgBr, Br goes out, taking away the electrons, creating a positive charge. Carbocation is formed, and then on carbocation, OH2 as a nucleophilic solvent, attacks on the positive charge, and we see that AgBr precipitate being formed, and the H plus, which is being removed here, reacts with NO3 minus, forming HNO3 acid. Okay, so that is it. The entire story of AgNO3 silver nitrate. Hope you guys understood. If you have any doubts, please put it down in the comments. I'll try to clarify it. Still, it's under 10 minutes. So, yeah, hope you guys found it useful and hope you understood. So, yeah, thank you. Keep learning. More videos are coming. Okay, sooner. Okay, bye.